Construction class. I want to show how to lay out the newest trend in the toy industry called these fidget spinners. Luckily, I haven't seen too many students in the class bring these into, but they are starting to make the rounds, and I wanted to show everybody how we could actually lay this out and make it. So first off, we need some of our tools. So class, we've got our 12-inch scale. What is this called again? The compass. We're going to use the compass. What about these tools here? These are kind of fancier looking, similar to compass. You guys, any of you know what this is? These are called dividers, and we're going to use dividers as a measurement. That's a transfer measuring tool. So, and we've got a couple of different styles of dividers that we use. Now, to use these, basically, the divider, we need to know a little bit about some stuff here. And we can't, oh, you still got me? Yeah. All right. So since this has 3 points to it, we can't really get a full diameter, but what we can have is the radius. So I'm going to use my pointed divider here, and I'm going to get approximation of the radius, which then I can transfer. This is a transfer measurement over, and I see that that is roughly 1 3/4 inch diameter. So our 1 3/4 inch radius, which will give me what size diameter? 1 3/4 will give me what in terms of my diameter? Anybody? 3.5 inches. Very good, Roberto. So now I'm going to basically start out here, and I'm going to draw my circle at 3.5 inch diameter circle on here. Now notice I go over a little bit up here. That's all right. So we'll take care of it. So that means my width of my board is just a little shallow. I'm just a little shallow on the 3.5 there, but that's all right. So we'll still get that in here. All right. Now I'm going to do the same thing here. We can pop out this bearing, so we can take a measurement on the bearing. Guys, I can measure this bearing from one point to the other side using my ruler, or I can get a more accurate measurement. Who remembers what this is called?
Dial caliper?
That's my dial caliper. So I'll take and I get a much more accurate measurement using my dial caliper, and I measured this. It is 865 thousandths of an inch, or roughly 7/8 diameter is what we'll say. So so I need to go 7/8. What's half of 7/8? Real quick, we will double both numbers. 7/8 becomes 14/16. Subtract 1, and we are at actually 7/16 would be where we're at. 7/16 is half of 3/4. No, that's not right, is it? What is half of 3/4, guys?
3/8.
3/8, right. So I'm going to reset this to 3/8, and I'm going to draw the center circle. See, sometimes we try to go fast, and when we're trying to quickly add and subtract and divide fractions in our head, we want to be able to do that, exercise the muscle in our brain. So I got my center line. Now, if we look at this, laying it out, we are also going to come over, and we need to know something about where that one is as well. We'll take another transfer measurement but first, before I do that, let me just scribe a line going across there, because I'm going to use that point. Now, you guys have seen this before.
Look like a Pokeball.
Yeah, looking like a Pokeball. So I didn't see that till now, but there you go. That was last year's craze, Terry. This year we're moving on to Pokemon Go was last year. All right. Now, you guys remember doing this from before. What did we use this? What did we use this geometric construction? What I'm doing now with my compass.
Whatever.
Yeah, we used this, and we did geometric construction, or this layout, to create the propellers for our airplane that we made. So in this case, I'm The geometry here is the same, a little bit different.
Now you're creating a flower like.
It looks kind of like a flower too, and I'm going to go back as well, and I'm going to bisect these arcs. Now, all of this is math terminology and geometry, guys, and we got to use and apply that math that we learn here, because we're going to need these bisected lines for our layout when we determine where each of these holes go in it as well. And again, we're back to 2 measurements here that I need to know. We were at 7/8 on the size of the hole, and if you'll notice, we're also going about 1/8 of an inch over, so we want to be roughly 1 1/8. I'm going to make it a little simpler. Would say 1 1/4 inch. What's half of 1 1/4 inch?
1/8.
Nope, half of 1 1/4 is
3/4.
3/4 plus 3/4 will give me 1 1/2. So 5/8 plus 5/8 will give me 1 1/4. So I reset my compass to 5/8, and I'm going to now come back and I'm going to draw from each of these points on the tip of the flower petal. So we'll call it flower petal for right now, or if you want to say the tip of the propeller on the airplane. So I hope that the Pokeballs kind of disappeared from view at this point now that we're a little bit gone. But you know, that's good observation that you made, Terriel, because a lot of this stuff is just geometric construction that designers and creators use. So now I've got each of these center points.
So I saw the flower light.
Yep.
Everything literally comes out of that pattern.
Yep. So we'll come back here and we're going to draw these circles. Now, and we're at that on there. Brody, I'm going to pick on you for a minute. So we got 3 circles. We got 360 degrees on a circle. How many degrees apart of each of these circles from each other?
How many degrees apart?
How many degrees apart? So are each. So we got 360 degrees total in the circle. Yep.
20?
Yeah, we're 120 degrees apart on each of these. That's our math there with our geometry as well. So in our degrees. So we're going to come back now. Now we changed this. We did the outside part of our spinner. Now we're going to go back to the 3/8 for our 3/4, and we will get that. This will be where our ball bearings go. Now, Roberto, your turn for me to pick on you. What do you think? What machine do you think I need to use?
To drill a hole?
Yep.
Drill
There you
press.
go. You already got it. Good. You're reading one step ahead of me. I like that. So we're going to use the drill press. What diameter drill bit do you think we're going to need to drill out that hole? If I got a 3/8 radius, but I need, what size diameter drill bit am I going to need? 3/8 plus 3/8 is
7.6.
6/8, which reduces to 3/4. Good job. All right, so I've got those holes. Now I haven't finished out these parts. Now here's the magic thing about this geometric construction, guys. Let's go back to the petals that we haven't used. And I'm going to basically make sure that this touches on each of them. And when we go to cut this, if I use these, notice how I switch, and we're starting to see the formation of this spinner in our geometry, our geometric construction, and our part layout that we've done. You guys all see it?
Yep.
Now, so I'm going to go and I'm going to use the drill press. I will drill out 4 holes. Do I want to only drill out 4 holes? if I'm smart, I can also drill out these 3 holes too, because it's the same radius. So that'll save me some saw cutting, and I'll get a better finish with the drill press. So I'll go ahead and I'll draw out those 7 holes, and then where do I go to cut out the curves?
Bandsaw.
Onto the bandsaw, and then I'll have my spinner. Of course, I want to do some sanding and everything. Maybe I'll put a radius. Remember, guys, this has got a radius on here. So what tool do I need to use to put the radius on it? This is a round over radius. What's the machine I want to use?
The router.
Yeah, so we can put that router bit in the router, and we can get a radius put on there too, and then I'll have a nice